question 8, 2011, 20/2012 Hong Kong Mathematics Olympiad, the heat event. The question goes thus: the quadratic equation, bracket opens, k squared, k to the power 2 minus 4, bracket closes x squared, minus bracket opens 14k plus 4, bracket closes x, plus 48 is equal to 0. Has two distinct positive integral roots. Find the value of values of k. All right, so quickly, what are we told? We are told that this equation has two distinct positive integral roots. All right, so we call our original equation equation 1, and we say let the distinct positive integral roots of equation 1 be a and b. Now, we know that if a and b are the roots of an equation, the resulting equation will be x squared minus bracket opens a plus b, bracket closes x, plus ab is equal to 0. So we call that equation 2. Now, if we multiply equation 2 by k to the power 2 minus 4, we'll have k to the bracket opens k squared minus 4, bracket closes x squared, minus bracket opens a plus b, bracket closes, bracket opens k squared minus 4, bracket closes x, plus a b, bracket opens k squared minus 4, bracket closes, equal to 0. Now, if you observe equation 1, the roots of equation 1, we had said let it be a and b, all right? Now, the roots of equation 2, okay, which we have modified, is equally a and b. The leading coefficient of equation 1 is k squared minus 4. The leading coefficient of our modified equation 2 is equally k squared minus 4. So that means equation 1 and equation 2 are equivalent, so we can equate coefficients. So that leads us, the coefficient of x in equation 1, all right, is 14k plus 4, negative into bracket 14k plus 4, bracket closes. The coefficient of x in equation 2 is negative a plus b, bracket closes, bracket opens k squared minus 4, bracket closes. Okay, and so we equated it, and that became my equation 3. Now, we also, the constant of equation, a modified equation 2 is ab, bracket opens k squared minus 4, bracket closes. Our constant of equation 1 is 48, and we equated it, that became our equation 4. Okay, now we make progress. Now, we're going to be on question 4 now. Question 4 is saying a times b times k squared minus 4 is equal to 48. So we can clearly see that the right-hand side is a positive integer. The right-hand side clearly is a positive integer. So therefore, the left-hand side must be a positive integer as well. Now, we have already established that a and b are positive integers. So it means that k squared minus 4 must be a positive rational number. That's because the denominator can also interact with a and b to still yield an integer. So k squared minus 4 must be a positive rational number. Now, k squared minus 4 is a positive rational number when k is a simple surd or an imaginary number or rational number. Now, that's not difficult to see. If k is a simple surd, that is example of simple surd as square root of 2, square root of 7, all right? So square root of 2 all squared, you have 2 minus 4, you're having an integer, all right? Square root of 14 also, okay, square root of 14, if you plug it in, you have an integer. So k, by reason of equation 4, k can be a simple surd. Now, k can also be an imaginary number. Examples of imaginary numbers are 2i, 4i, 5 over 2i, all right, 13 over 4i. Now, k can be this because when you square an imaginary number, it results in an integer. It results in a rational number which satisfies the what we want. That's k squared minus 4 must be a positive rational. All right, but if we consider equation 1, we see that k cannot be a simple surd, because if k is a simple surd, yes, k squared minus 4 would eventually become a rational number, but 14k plus 4 will not become a rational number. It will still be a surd. and that means that equation 1 will not yield positive integral. All right, so that means that k cannot be a surd, a simple surd. On the other hand, if k is an imaginary number, again, k squared minus 4 would yield a rational number, but 14k plus 4 will not yield a rational number. 14k plus 4 will be an imaginary number, or more precisely, a complex number. And again, if that is the case, equation 1 will not yield integral root as the question suggests. So that leaves us with only one option, which is k being a rational number. So we have seen that k, yes, for k squared minus 4 to be a positive rational, yeah, k can be a simple surd, k can be an imaginary number, but we've seen that if you plug that into equation 1, it doesn't work. So the only possibility left is k being a rational number. Now, so since we've established that, we say let k equal to x over y, where x over y is in reduced form. What that means is that the GCD of x and y is equal to 1. X and y are natural numbers, that is positive integers, because we've established that k squared minus 4 must be a positive number. Reason being that a and b are already positive, so it must be positive if it must agree with the right hand side that is equally positive. So x and y are both positive integers. That is, they are natural numbers. Now, k squared minus 4, we now plug in x over y where we find k. So k squared minus 4, this becomes x over y all squared becomes x squared over y squared minus 4. And if you simplify this, you have x squared minus 4y squared divided by y squared. Now, equation 4, that's the equation we have up here, a times b times k squared minus 4 equal to 48 becomes a times b, our k squared minus 4 is now x squared minus 4y squared divided by y squared is equal to 48. Now, this is equivalent to, you multiply through by y squared. Okay, this is equivalent to saying, of course, y is not equal to 0. We've established that y is a natural number. So when you do that, this is equivalent to a times b times x squared minus 4y squared is equal to 48y squared. So this is equation 4c. Now, we had earlier on established that GCD of x comma y is equal to 1. What that means that x and y share no common factor. And in particular, it means that y cannot divide x. And if y cannot divide x, y cannot also divide x squared minus 4y squared. Okay, so we're making reference to equation 4c, okay, because this is an equality. It means the left-hand side value is the same as the right-hand side value. So far, we've seen that y squared, which y is a factor, cannot divide x squared minus 4y squared. Reason being that the GCD of x and y is 1. So since that is not possible, it means that it is x squared minus 4y squared that must be a divisor of 48, because we clearly see that x squared minus 4y squared and y squared share no common factor. So therefore, x squared minus 4y squared must solely be a divisor of 48. Must be a divisor of 48. Now, so we've said that from equation 4c, right-hand side, all right, is a natural number. A and b are natural numbers. So therefore, x squared minus 4y squared must also be a natural number. So two things, x squared minus 4y squared is a natural number and is a divisor of 48. So we have, okay, that's equation 4c. Now we want to look closely at x squared minus 4y squared. Now x squared minus 4y squared is the scenario of difference of two squares, all right? So this is x squared, this is minus 2y all squared. So if you factorize this, it gives us x minus 2y times x plus 2y. So this means that x squared minus 4y squared can be expressed as a product of two numbers. Do not forget that both x and y are natural numbers that differ by 4y. Okay, what do we mean by this? Now, if you add x minus 2y, if you add 4y to this, you get x plus 2y. Okay, so that means that the difference, or if you choose to, let's say, x plus 2y minus x minus 2y, you would get 4y. So that means that this is a product of two numbers that differ by 4y, okay, which is the same thing as product of two numbers whose difference is a multiple of 4, all right, because every number that can be expressed as a form of 4y is a multiple of 4. Now, using the fact that x squared minus 4y squared is a divisor of 48, which we've established already, and asterisk, which is what we established up here, it is sufficient for us to find all pairs of two numbers that are divisors of 48 that differ by a multiple of 4 and product less than 48. Now, what this means is that we have this equation 4c, we have a times b times x squared minus 4y squared equal to 48y squared. Okay, so we have established that x squared minus 4y squared is a divisor of 48. We also established that x squared minus 4y squared can be expressed as a product of two numbers that differ by a multiple of 4. So we're wanting to use that fact, all right? We want to find all divisors of 48, okay? We want to pair any two of them that their difference is a multiple of 4 and their product is less than 48. Now, there are only two possible pairs, and these pairs are 2, 6 and 4, 8. 2, 6, of course, you will know that x minus 2y is less than x plus 2y. So the smaller number is x minus 2y, while the larger number is x plus 2y. So solving x minus 2y equal to 2 and x plus 2y equal to 6, if you solve it, it yields x equal to 4, y equal to 1. Solving x minus 2y equal to 4 and x plus 2y equal to 8, it yields x equal to 6, y equal to 1. We had said that our k, what is our k? K is equal to x over y, where x and y are relatively prime. So this gives us that x equal to x, k equal to x over y, which equal to 4 over 1 or x over 1. So we have our k, two possible values of k as at now, which is 4 or 6. Now, so far, we have been analyzing and working with equation 4. So we need to now bring equation 3 into the picture. So we plug 4 equal to k equal to 4 or 6 into equation 3. What's equation 3? A plus b times k squared minus 4 is equal to 14k plus 4. Now, when k equal to 4, we have a plus b times 4 squared minus 4 is equal to 14 times 4 plus 4. And that gives us 12. 12 times a plus b equal to 60. And dividing through by 12, we have a plus b is equal to 5. Now, when k equal to 6, we have a plus b times 6 squared minus 4 is equal to 14 times 6 plus 4. Now, this gives us 32 times a plus b is equal to 88. So this becomes a plus b is equal to 11 over 2. But we know that a and b are both integers. And so their sum must be an integer. So therefore, a plus b, therefore, k cannot be 6, because when k is 6, it yields a result that suggests that a plus b is not an integer. So the only possible value of k here we take is k equal to 4. So when we plug k equal to 4 into our original equation, it becomes 12x squared minus 60x plus 48 equal to 0. And this is equivalent to 12 times x minus 1 times x minus 4 equal to 0. This yields roots 1 and 4, which are distinct positive integers. Therefore, k has only one value, and that is